Hello, so I'm going to present the main ideas behind our work, detecting melanoma fairly, skin tone detection and debiasing for skin lesion classification. You can see the preprint and the code with the QR codes there. So to give an overview of what we're contributing, firstly we propose a simple and efficient variation on Kinyan et al.'s skin tone labeling algorithm. And secondly, we assess the effectiveness of popular debiasing techniques for the task of skin tone bias removal in melanoma classification. So in terms of motivation, a recent paper by Groh et al. Shows that CNNs perform better at classifying images with similar skin tones to those the model was trained on, which is to be expected. And it follows that then when the training data is of mostly light-skinned patients, models will probably perform worse on patients with darker skin tones. And we were able to corroborate these claims with our own models, and you can see that in the table there. So having manually inspected the ISIC archive data, which is quite a popular training data set for melanoma classification, we hypothesized that the dataset is imbalanced with regard to skin tone. And this was supported by our skin type labeling algorithm, which you can see in the plot on the left. And I'll go into the skin type labeling algorithm in a minute. So the best way of dealing with the issue of skin tone bias would be to rebalance the training data by collecting more high quality images in darker skin tones. But that's likely to be slow and take many years. So as a partial solution, we are investigating here mitigating the skin tone bias by removing skin type information from the feature representation during training. So looking at the methods, firstly at the skin tone detection algorithm that we proposing as an extension of Kinyan et al.'s work. Basically, it just converts pixel values into ITA values and then translates these into Fitzpatrick skin type values using just thresholds. And the basic difference between ours and the previous work is that we try to tackle poor lighting and shadowing by only using the lightest patch from a number of samples following hair removal processing, and that's instead of just segmenting and taking the whole healthy skin area. You can see the hair removal and the sampling technique there. And to just do a quick rundown of the debiasing methods that we experimented with, this is all previous work. So the first one is Learning Not to Learn by Kim et al. And it uses an auxiliary head to identify and remove a label bias from the feature representation. It uses an auxiliary regularization loss, which minimizes the mutual information between the feature embedding and the targeted bias. And then gradient reversals also applied to the auxiliary bias classification loss during backpropagation, which acts as an additional bias removal tool. And then the goal is that the primary classification head learns to classify using a feature embedding that's hopefully independent of the targeted bias, which is skin tone in our case. And then the second one's called Turning a Blind Eye by Alvey et al. And it's similar in that it uses an auxiliary classification head, but this time it uses a confusion loss in place of the regularization loss, and it doesn't use gradient reversal. But we do experiment with adding gradient reversal into it as well, which was suggested in the Learning Not to Learn paper. So we denote this CLGR in the results that you'll see later for confusion loss with gradient reversal. So both of these methods require bias labels, and we use skin tone labels, either provided by humans in the case of the Fitzpatrick 17K data, or provided by our labeling algorithm in the case of the ISIC data that we investigate. So for results, we show that using a turning a blind eye head with gradient reversal, so the CLGR method, can reduce the disparity between lighter and darker skin tones, even just a little bit. And yeah, the improvement's minimal, but we took that as a proof of concept to investigate the method on the ISIC data. So I should have said this is on the Fitzpatrick 17K data, which has human labels, and then we take that as a proof of concept and apply it to the ISIC data with our automated labels as the target bias. So for the ISIC data, we also attempt to mitigate the hypothesized skin tone bias using the same debiasing methods with the automated skin type labels as the target bias. To test this, we use a variety of data sets with different geographical and skin tone distributions and see some improvement using the turning a blind eye method, but less or no improvement using the other methods. And just some references there. Thanks a lot, and I'll be here to answer questions on the day.